Hello again. We're back for the second part of the 5.5 note. We started yesterday or last day looking at this formula up here, which looks at the relationship between the number of moles of something and the amount of mass, using big M, which is molar mass. Okay, today I want to take up a little bit of the homework from page 182, and then from there we're going to step into our last calculation for this section, which will be the end of 5.5. All right, so let's go back to page 182. I'm going to pick up a couple of questions. All right, so let's start with a fresh. So if I go to page 182, and let's start with question 11. Let's start with a hard one. Let's start with 11C. Okay, 11.C says calculate the mass of a sample of aspirin if we have 1.25 moles, and the formula is given there. Okay, so for 11C, question is the number of moles is given as 1.25 moles, and the question is what is the mass? Now, I'm playing with different pens here. So, we know that our formula is mass equals number of moles times molar mass. Right, there's our basic formula. So if I want to solve for the mass, I need to know number of moles, which I do in the question, and the molar mass, which I can figure out, even though it's a bit of a tougher one this time. So, there's my given, there's my required to find. My approach is going to be to use M equals N times big M, and to do that, I need to start by calculating big M. So big M for aspirin. Aspirin is, it tells me C9H8O4. C9, so I need 9 times the molar mass of carbon plus 8 times the molar mass of hydrogen plus 4 times the molar mass of oxygen. Right, let me fix this up here. Molar masses. Okay, now, molar mass of carbon, 12.01, 12.00 actually, I believe, 12.01 plus 8 molar masses of hydrogen, which is 1.01, plus 4 molar masses of oxygen, which are 16.00. So my molar mass, let me do the calculation here. .17 grams per mole. So there's my big M. There's my molar mass for aspirin. Now I can go back and I can solve for the mass using the number of moles that was given in the question and the molar mass that we've just calculated here. Okay, so let's do the math. Mass is equal to number of moles times molar mass. Number of moles is 1.25, and the molar mass is 180.17. Getting 225 grams. Okay, so if I'm doing a lab, which we could do in this course, involving aspirin, I might be doing any labs the way things are looking, but anyway, that's a whole other issue. So therefore, there is 125 grams of aspirin. aspirin in 1.25 moles. That doesn't sound right, does it? Oh, 225 grams. Sorry, that's better. Of aspirin in 1.25 moles. Okay, let's move on to 13 from the homework, and again I'll choose C. So it says, for each of the following masses, calculate the number of moles. So C tells me that I have the mass, little m, equal to 1.3 times 10 to the power of 3 grams, and the chemical is calcium CaCl2, calcium chloride. It's my given. My required to find is, in each of the following masses, calculate the number of moles. Calculate little n. Alright, so if I look back at my formula that I had up here a minute ago, formula was mass equals number of moles times molar mass. If I rearrange this equation and bring the big mass down here, I end up with n equals little m over big M. So my approach is going to be little n is equal to mass divided by molar mass. Okay, but I don't know my molar mass yet, so I'm going to have to, before I can do anything, calculate my molar mass. It's calcium chloride, so I need 1 molar mass for calcium plus 2 molar masses for chlorine. Right, now, calcium in the textbook is 40.08. And chlorine, if I remember correctly, is 35.45. Let's just double check. Yes. Okay, so my total molar mass, let's do the calculation here. I'm getting, oh dear. Getting 110.98 grams per mole. Okay, so there's my big M. So now I know I can calculate my unknown n equals, because I know little m from the question, and I know big M that I just calculated here. So I can go ahead and do my calculation. So to solve for this, n is equal to little m, which is 1.3 times 10 to the power of 3 grams. That was given in the question, remember, way back up here. And then divided by the molar mass that I just calculated, which is 110.98 grams per mole. Getting 11.7 moles. Remember our symbol for mole. Gram is G, kilogram is kg, moles is MOL. So my number of moles therefore there is 11.7 moles of CaCl2. Okay, so there's a there's a quick look at some of the homework from yesterday. Right now I want to go ahead and move on to our new note and our new idea for today. Okay, so the other thing that we can do, so we did this already earlier, way back in section 5.2, I believe. Let's just go back there. Okay, back in 5.2, we had this formula here. This formula said, if I know how many moles I have of something, I can figure out how many particles I have, atoms or molecules, because I know Avogadro's number. Or, if I know how many particles I have, I can use that to determine how many moles, because I know Avogadro's number. So big N is equal to little n times Na. Okay, let's go back to today's work. And it says we can also figure out the number of moles using Avogadro's constant. So again, we've already done this once. I'm just going to come back and we're going to revisit this. And then after we're done with this, actually I'm not even going to do another of these because we've already done a bunch of these earlier. Right? But what this means is I've got a relationship here between the number of particles and the number of moles. If I go back up to here, I have a relationship between mass and number of moles. So in this equation here, I have number of moles. And in this equation here, I can calculate the number of moles. So I've got two different formulas, and on either side of this, this relates moles to number of particles, and the other formula relates number of moles to mass. So what I can ultimately do now is I can convert from mass to number of particles, right, or from number of particles to mass. Okay, and that's our last piece here for this section. So if I want to figure out, let's just move up a little bit here. Okay, so this is a really important let's just go with a different color. Let's go with green. This is a really important flow chart. This tells me that there are three ways to talk about the amount of chemical that I have. I can report the amount of chemical as either a mass, how many grams of the chemical do I have? I can tell you how much chemical I have in terms of moles, how many moles do I have? I can also tell you how much chemical I have in terms of how many particles there are, number of atoms or molecules. So all three of these in pink here are ways to tell you how much chemical there is. And if I have 1 mole of a chemical, let's say helium, I know that the 1 mole represents 6.02 times 10 to the 23rd molecules, or atoms actually, of helium. And if I know that I have 1 mole of helium, so not only do I know that I have 6.02 times 10 to the 23rd atoms, but I also know that it has a mass of 4.00 grams. So if I've got 4 grams, I know I have a mole. If I have a mole, I know I have 6.02 times 10 to the 23rd atoms. What that means is, if I know I have 4 grams, which is a mole, then I can convert to the number of particles. So I can, if I tell you how much of any one of these quantities, again, let's just switch to a different color here, or actually let's go a different color. Let's go to blue. If I tell you how much matter I have in terms of atoms or molecules, I can tell you what it weighs, what's its mass. Or vice versa, if I tell you how much mass of a chemical I have, you can calculate how many atoms or molecules there are. Now, there's no direct way to go from here all the way to here, right? What I have to do is do 2 steps. I've got to do a calculation that converts mass to moles, and then once I know the number of moles, I can convert it to number of particles. Or vice versa. If I'm trying to figure out how much mass I have given a certain number of particles, I can't do this, right? I can't jump from from big N to little m. What I can do is I can use big N to calculate little n, number of moles. Then I can use number of moles to calculate the mass. Whoa, that looks horrible. Okay, we're going to actually be doing a few of these, and you'll see once we've done them, we're just using those two very simple formulas that we had way back when. This one here and this one here, the ones that we've been using over the course of the last week or so, converting number of moles here to particles and converting number of moles to mass and vice versa. Okay, so let's get rid of all this stuff that I've just thrown up on here, and let's go back to my simple template that I have right here. Oops. So alright, so this, like I said, is probably the most important little visual that we're going to be using. Okay, so you may want to come back to this. You may want to actually practice writing this down. All right, mass to moles, moles to particles, particles to moles, moles to mass. Okay, so let's try a couple. Actually, I'm going to jump all the way down. Okay, I'm going to do the sample problem, which is on page 184. I'm going to skip these for now. Okay, so let's go back to here. Let's start with a clean page, and let's look at the sample problem, which is sample number 6 on page 184. Now, the question says, potash fertilizer contains a number of different potassium compounds and containing potassium chloride. What mass of potassium chloride contains 3 times 10 to the 25 formula units? Here's that word again. Formula unit just means molecule. Contains that many molecules of potassium chloride. When they give us a break, they give us the molar mass. They calculated it for us as 74.55. Okay, so let's look back to the question here for a minute. So it says we have 3 times 10 to the 25 molecules of KCl. So there's my given. Okay, 3 times 10 to the 25 molecules of KCl. Note, molecules is little n. Okay, what I'm required to find, it says, what mass of potassium chloride, right, contains this many molecules. So I'm now looking for an unknown, which is mass. Now, there's no formula that we've done in this course yet that has mass and number of particles in it. The only formula that we have that includes mass is the formula that contains the number of moles. So if I go back to my my note here, whoops, undo. Okay, so I know big N, and I'm trying to calculate mass. And like I said, there's no way to get from here to here directly. What I have to do is use the number of molecules here to calculate the number of moles. Then once I know the number of moles, I can calculate the mass. Right? So that's why this picture is so handy. It tells me there's no quick and easy way. If I said I've got 3 times 10 to the 25 molecules of KCl, how many moles is that? You could do a calculation. If I said I've got 4.2 moles of KCl, what's the mass? You could do the calculation. But if I said you've got this many molecules, what is the mass? There's no way to jump from here all the way to here in one step. I've actually got a step 1, step 2. So I'm going to start here by converting my number of molecules into my number of moles. All right, so back to my solution here. Okay, my solution says before I can calculate big N, before I can calculate mass, Okay, so I only have one formula for mass. Oops, undo. I only have one formula for mass. That is mass is number of moles times molar mass. I know what the molar mass is. They actually told me in the question. Normally you would have to calculate the molar mass. 74.55 grams per mole. Okay, so I'm trying to solve for this. That's what my question's asking for. To do that, I need to know molar mass, which I know, but I don't know the number of moles yet. So I've got to find a way to calculate the number of moles. Oh dear. Calculate the number of moles from the big N. Now, we've got a formula that says number of moles is equal to big N divided by Avogadro. Right? Little n equals big N divided by Avogadro. Now, I know what big N is, and I know what Avogadro is. Right? So I can go ahead now and put my numbers in. The big N is 3.00 times 10 to the power of 25. My Avogadro's number is 6.02 times 10 to the power of 23. Are you starting to remember that number yet? Right. It's not going to be long. You'll be seeing it in your sleep. Okay, so I've got 3 times 10 to the 25 divided by 6.02 times 10 to the 23rd. I'm getting 49.8 moles. Okay, 49.8 moles. Now that I know my 49.8 moles, I can go ahead. I know little n, so I can go ahead and solve for my unknown here, little m, because I know little n and I know big M, which was given to me here in the question. So let's go ahead. Oops. There's my approach. Now I'm going to solve by substituting in mass equals n times big M, or 49.8 moles times the molar mass of 74.55 grams per mole, and I'm getting 3,715 grams. All right, so that's it. So the question says if you have 3 times 10 to the 25 molecules of KCl, how much do they weigh? Right? So you've got to go through and say, okay, well, if I know I've got that many molecules, I can calculate the number of moles. Once I know the number of moles, I can say that what is the mass of that many moles. So my phrase here, therefore, we have 3,715 grams of KCl. All right, so this is the key right here. Right, it is this picture that I keep messing up. Right, and this is the way we're going to look at getting from our knowns to our unknowns, our given to our requireds. Okay, so I'm going to stop there for now, and I'm going to ask you to try to do questions 15 to 18 on page 184. Right, the answers are at the back of the book. The answers are also in that document that I'm creating as my solutions manual for the course. All right, so try those for now. There's some additional questions on the next page, and I will come back to those in our next day. All right, so good luck with these questions. Again, just keep coming back to this. Remember, what are your variables? Little m for mass, little n for moles, big M for molar mass. Right, so again, this is pretty important in terms of how we're going to solve these. It reminds me what the variables represent, right? And then this template up here, this series of of steps can help me to go from one